All right then, probability. Let's start off with some definitions, of course. So we're going to be talking about different events. So what do I mean by an event? Is that's a possible, observable, occurrence. So something like a genotype of an organism, a phenotype such as flower colour, or a lot of the examples we're going to be using aren't going to be biological, they're going to be things like rolling dice. So a particular dice roll, that would be another example of an event. But then once the event's actually happened, it becomes an outcome. So for example, we're imagining all the different numbers that we could get from our dice roll, and then we roll the dice and we actually get one of them. So that's when a particular event actually occurs. So then what is probability? I think you probably have a good instinctive idea of what that is. And actually it all gets pretty philosophical when you start getting into it, and there's a bit in the textbook about that. But I think of it as the likelihood of a particular outcome happening. So we can think of this, so I like to think of this as the proportion, that's an important way of thinking of it, of times that we'd get this outcome if we repeated the observation indefinitely. So if we rolled the dice thousands and millions of times, or if we assayed thousands and millions of individuals to look at their genotype, if we looked at the colour of thousands and millions of flowers. So that's one way of thinking about probability that I like. And we write the probability of an event A so P brackets A, so the probability of A, and A here is a capital letter. That's important. So you can use something that's useful to you as the probability, you know, a meaningful letter. Okay, so a couple more things to say. We're going to be talking first of all about independent events. So that means that the outcome of one observation does not affect the outcome of another. So for example, if I roll the dice one time, then that's not going to have any effect on the outcome of the second time I roll them. So several sequential rolls of the dice. We're also going to be talking about mutually exclusive events. So that means if one event happens, then the other possibilities can't happen. So for example, if I roll my die and I roll a 6, then I can't also in that same roll get a 1 or 2 or 3 or 4 or 5. if I roll a 6, for example, I can't roll a 2 on the same experiment, on that same observation. But for example, I could roll a 6 and also observe that the die is red, for example. Those would be non-exclusive events. And the last concept I want to talk about is the idea of exhaustive. An exhaustive set of events. We could also think of this as the sample space. That's another word for it. And that is all the possible outcomes of an experiment. So when I say experiment, that kind of means an observation in statistics. I don't mean a whole, experiment as we think of it in science. I'm just thinking about one observation. In fact, let's just write observation. That's going to make it simpler. So for example, for a standard 6-sided die, I've got the curly brackets again, so that gives me 1, 2, 3, 4, 5 and 6. Those are all the possible outcomes. That's an exhaustive list of all the results I could get. So that's called my sample space. That's an exhaustive set of events.